Welcome to Engineers Academy. Subscribe to my channel and click on the bell icon to receive the notification for the upcoming videos. I am going to solve this problem 1284. In this problem we are given that the van travels over the hill described by this function, right? So we are given that this van is traveling about this hill and this is y of x function, right? So we can write that y is equal to, let me write it here, right? So y is equal to minus 1.5 into 10 raised to the power minus 3 x square plus 15, right? And this is in feet, remember. So it is said that if it has a constant speed of 75 feet per second, right? So it has a constant speed of, so we are given the velocity magnitude, right? So the velocity magnitude is 75 feet per second, and this velocity, since this is the magnitude of the velocity, so this velocity will be tangent to this path, right? So if we want to draw the velocity vector, so then that velocity will be tangent to this path, right? So and the velocity direction will be, let's say like this. Let's say this is the velocity, so this velocity vector will be tangent to this y of x function, right? So this path. So we are asked to determine the x and y components of the van's velocity and acceleration, right? So we have to find vx, vy, ax and ay at x is equal to 50 feet. So now this is y of x function now. So if we want to find the velocity, right, so if we take the derivative of this is y, right? So this will be, if I apply the derivative with respect to t, right? So if this is dy by dt, so then this will become y dot, and y dot will be the velocity in y direction, right? And since y is a function of x and x is a function of time, so then we have to apply the chain rule, right? So this will be minus 1.5 10 raised to minus 3, and the derivative of this will be 2x, and then we have to take one another derivative, so that will be x dot. So this means that this equation comes out to be that y dot vy is equal to, and this 2 into this thing, right? So 2 into minus 1.5, so let me write, so 2 into 1.5 will become 3, so minus 3 into 10 raised to the power minus 3, and then x, and x dot is vx, right? So x dot is the velocity component in the x direction. So now we are given this velocity magnitude, so then the velocity magnitude will be equal to vx square plus vy square, and this will be equal to v square, right? Or we can write it on the other side of the equation, so then this will be v square, right? So vx is unknown, so I will write vx square, and if we write this thing vy is equal to this thing in terms of x, right? And we want to find vy at x is equal to 50. So now if I put x is equal to 50 in this equation, so that will be the velocity component at x is equal to 50. So this will be minus 3 into 10 raised to the power minus 3, and we will put this x is equal to 50 feet. So this comes out to be minus 0.15 vx. So this is vy equals to minus 0.15 vx, right? So we can write it here. So this will be minus 0.15 vx, and this will become whole square, and this will be equal to v square, and the velocity magnitude is given, that is 75. So this will become 75 square. So now if I take vx common from this equation, so this will be, if I take vx square common, so this will be 1 plus 0.15 whole square, and this will be equal to 75 square. So we can find vx will be equal to 75 square divided by 1 plus 0.15 whole square, and then this is vx square, so then we have to take the square root. So this gives us vx magnitude, which is 74.1, right? So vx comes out to be 74.17 feet per second. And now if we put this vx value in this vy, so this will give us the vy magnitude, so then vy will be equal to So this will be minus 0.15 into Vx, which is 74.17. So this comes out to be Vy is equal to minus 11.13 feet per second. Now if we draw these two components of velocity on this diagram, right, so this means that Vx is in the positive x direction, right? So let me remove this first. So let's say that this is at x is equal to 50, so Vx is acting in the positive x direction. So this is our positive x, so I will have to draw it like this. So then this will be our Vx vector, and then as we can see that Vy is negative, right? So this will be our Vy, right? So this will be parallel to this y-axis. So the real velocity vector is in this direction, right? So this is the real velocity vector. So we can write that this is Vx, this is Vy, which is negative in the negative y direction, and this is the v vector. So this means that this velocity is tangent to this y of x curve. Now if you want to find the angle of this v with the positive x-axis, right, so if you want to find this theta, right, so we can draw a triangle here, or we can draw this Vy here as well, right? So then we can apply tan theta, right? So if I apply tan theta, so tan theta will be equal to this Vy divided by Vx, right? So Vy divided by Vx, or in other words we can write this Vy as dy by dx by dt, sorry, and this Vx by dx by dt. So dt will cancel out, so this will be equal to dy by dt by dx. Now to find this theta, we have to take the derivative of this y of x function, but the derivative should be with respect to x, right? And so this y dot is the derivative of this y of x with respect to t. So remember that this derivative will be with respect to x, right? So if I take the derivative of this with respect to x, so then this will be dy by dx, and then that will be 2 times 2 into minus 1.5. Let me write it this like this, 10 raised to the power minus 3x, right? And this will become 0, and then there will be no x dot. Remember, when this is dy by dt, so then we will have to apply the chain rule, right? Yes, but now this is only the derivative of y with respect to x. So now we want to find this theta when x is equal to 50 feet, right? So we are asked to find this x is equal to 50, right? So then I have to put x is equal to 50 in this equation, right? So if we put x is equal to 50, so then this derivative comes out to be minus 0.15, right? And we can confirm this value by taking this ratio, right? So Vy is what? So Vy is this thing. So I can write this is minus 0.15 into 74.17, and again Vx is 74.17, so this will cancel out in this ratio. So this means that dy by dx is equal to minus 0.15. So we can find this theta. This theta will be equal to tan inverse, and tan inverse minus 0.15, and this theta comes out to be minus 8.531, right? So we can write that this is minus 8.531 degrees, right? So this theta is negative, right? So this means that the slope is negative, right? So now this means that this theta is minus 8.53, and this theta is measured clockwise, right? So this is 8.531, right? So now if I draw this free body diagram, right? So if we draw a tangent axis, right? So let's say this is the tangent axis and this is the normal axis, right? So from this velocity is tangent to this y of x function, this path, right? So this means that if this angle is 8.531, so this means that this tangent line to this path is making 8.531 degree angle, right? So this angle is 8.531 degrees. And similarly, as we can see that this normal axis is making 90 degree with this t axis, and this y is 90 degree, making 90 degree with this x axis. So this means that this angle is also 8.531, right? So I will write it that it is 8.531 degrees. Now we have found Vx value, so I will write Vx value, which is 74.17 feet per second. Vy is minus 11.13 feet per second. Now we will find Ax and Ay components. Now to find the acceleration components, we have to take the second derivative of this y of x function, right? So this is the first derivative, so we will have to take another derivative, so this will be y double dot, and then this will be minus 3 10 raised to the power minus 3, and then we have to apply the product rule to this, right? So this will be x double dot plus x dot square, so this will be ay, and this will be minus 3 into 10 raised to the power minus 3, this will be x, and this is ax, x double dot is ax, and this is vx whole square, right? So now I can write this like this. So this is ay, and we want to find ay at x is equal to 50, right? So at x is equal to 50 feet, ay is equal to minus 3 into 10 raised to the power minus 3, and this is x value is 50, right? And ax is unknown, and plus vx square, so this is vx value, which is 74.17, right? So I will write 74.17 whole square. Now let's say that this is equation A, right? So now in this statement we are given that this car has a constant speed of 75 feet per second, and is I have discussed that this velocity, this constant velocity, which is 75 feet per second, this is tangent to the path, right? So this means that if we find the tangential acceleration, if we find the acceleration which is parallel to this tangent line, so then that acceleration will be 0, right? So if I write that the tangential acceleration for this car will be equal to 0, so what will be the tangential acceleration? So that acceleration which will be tangent to the path, right? So this means that acceleration which will be parallel to this wave velocity will be equal to 0, right? Since the tangential velocity is constant, right? So now if we find the ax, if you want to find ax and y components, and let's say that this is the ax, right? Let's say that this is that car and this is that tangent, right? So I have discussed this already, and this is that x and positive x and y axis. So let's say if this is a x-axis is, so the component of acceleration along x, right? And let's say that this is the acceleration component along y, and now we know this angle, right? So this angle is 8.531, right? So now if we find the components of this ax and this ay along the t-axis, so the component of x along this t-axis will be, the component of this ax along this t-axis will be this vector, right? So this is ax along t, right? So we can write this, so then this will be, this vector will be ax cos of 8.531, right? So we can write that this red vector is ax cos of 8.531 degrees. And now if we find the component of this ay, right? So this is the ay component of the acceleration. So if we resolve this ay, and if we find the component of this ay along this t-axis, right? So let's say that this is that vector, this is that component which is parallel to this at, right? So then this vector will be the sine component of this ay, right? So this means that this component will be ay sine of 8.531, right? So now if we add both of these vectors, so then as we have discussed that a tangential is equal to 0, right? So the tangential acceleration for this car will be equal to 0 since the tangential velocity is constant, right? So then as we can see, this is our positive t direction, so we have to write this. So this will be ay sine of 8.531 minus ax cos of 8.531, and this will be equal to 0 since this will lead to the tangential acceleration, right? So now we have two equations, this equation A and this equation B. So now we have two equations and two unknowns. So we can substitute this equation A in this, so this will give us the AX acceleration, right? So now I can put AY equals to this thing, I can substitute AY in this equation. So this will be minus 0.15 AX minus 16.50 sine of 8.531 minus AX cos of 8.531 equals to 0. Now when we simplify this equation, right, so the x comes out to be minus 2.42 feet per second, right? So this is simple mathematics, you people can do it, right? So x comes out to be minus 2.42 feet per second. So now if I put ax in this equation, so then in equation A, so then we will be able to find this ay as well, right? So then ay will be equal to minus 0.15 ax, and x is minus 2.42 minus 16.50. so this will give us ay, and remember that this ax comes out to be negative, right? So this means that this assumed direction of ax is not accurate, right? So this we need to reverse this direction, right? So ax is actually acting in this direction, right? So if I draw it here, so this is a x direction which is in the negative x, right? So now when we solve this equation, so then ay comes out to be minus 16.14 feet per second square, and again ay is also negative, right? So this means that the x direction is this and ay direction is in the negative y direction. So now we have found vx, vy, ax and ay, right? So this is the solution of this problem.